Hello everyone, good day. So our topic for today is the proof by contradiction. So last time we had already done the proof, the direct proof, and also the proof by contrapositive. Now we will go deeper into the proof by contradiction. So as we all know, it's an indirect way of dealing with proofs, and based on its definition or description, the first thing that we need to do is we suppose that both P and negation of Q are true. Then we use the steps from the direct proof of if negation of Q, then negation of P, to show that the negation of P must be true. This will lead to the contradiction P and negation of P, completing the proof by contradiction. So take note for this one. So we suppose that the P is true, and then the negation of Q is also true. So this is our assumptions. Then we make use of the negation of Q in the first steps, and then we need to come up with the negation of P as an output, making use of the negation of Q. Later in the process, we can get a negation of P as a result. So we must prove that the negation of P is true. And then we can come up with a contradiction of the given P and then the negated P. So I think we have an example so that we can materialize it. So this is an example. If 3n plus 2 is even, then n is even. So we need to identify first our P and our Q. Let me have another color of pen so that you can see. Okay. So this is our P. This is our Q. So take note that the P is Pn plus 2 is even. And then our Q is N is even. So accordingly, if you will get the negation of P, it will become 3n plus 2 is odd. And then the negation of Q, we will have n is odd. So based on the description that we had a while ago, so we start by supposing the P and the negation of Q are true. So suppose 3n plus 2 is even. So take note, this is the P. And the negation of Q, N is odd. By definition of odd number, n is equal to 2a plus 1 for some integer a. Then the 3n plus 2 here will just be equal to 3 and then the n plus 2. But we know that the n is 2a plus 1. So you will have 6a plus 3 plus 2. Therefore, 3n plus 2 will become 6a plus 5. But I think we can convert it into a more simplified number. So I think it'll just be 6a plus 4 plus 1. So it will become 2 and then 3a plus 2 plus 1. And then let 3a plus 2 is equal to, we can have c for some integer c. Then we'll have 3n plus 2 will just be equal to 2c plus 1. So take note that 2c plus 1 is, this is a definition of an odd number. By definition, 3n plus 2 is odd. This is a contradiction. P and negation of P. Therefore, the statement 3n plus 2 is even. Then n is even is also true. So I think we're done with the proof by contradiction. So you can have this an example. Let's try another example. Okay, let's have this example. The sum of three odd numbers is odd. So as you can see, there is a need to convert it to f-then form. So let's convert it first. So we can have it as if P, Q, and R are odd numbers, then P plus Q plus R is also odd. So to do it by proof by contradiction, so the first thing that we know is we need to have the identify the P and the Q. So our P here is this one. So P, Q, R are odd numbers. And our Q here is that P plus Q plus R is odd number. Or the sum of P plus Q, PQ and R is odd. So to get the negation of it, so the negation of P, you can have P, Q, and R are even numbers. And then here, the negation of Q, you can have P plus Q plus R is even number. So let's start with our assumption. So suppose P and the negation of Q are true. So we will start with suppose P, Q, and R are odd numbers. And P plus Q plus R is even. Then, by definition of an even integer, P plus Q plus r is equal to 2a. For some integer a. Since p, q, and r are odd numbers, then p is equal to 2b plus 1, q is equal to 2c plus 1, and then r is equal to 2d plus 1. For some integers b, c, and d, then we can have 2b plus 1 plus 2c plus 1 plus 2d plus 1 equals 2a. Where did we get it? Here, this one. This is our given, right? So this is the p, this is the q, and this is the r. So let's continue. So as we continue, we can simplify it. So we will be having here 2b plus 2c plus 2d plus all the ones, 1, 2, 3. So plus 3 is equal to 2a. From there, you can place the 2 outside. So you have plus b plus c plus d plus 3 is 2 plus 1, right? So this 1 here and then plus 1 outside. So that's 2a. And then you can let b plus c plus d plus 1 equals e. So you can have there for some integer e. So you can have here 2e plus 1 is equal to 2a. And you can see here, this is a contradiction. So we can conclude that, therefore, the sum of 3 odd numbers is odd. Okay, I think that's all for our examples. I'll be giving you activities later.